Hello, ladies and gentlemen. I hope you are having a good day. Our lesson today is going to be about a new kind of logarithm called a natural log. And if you have a TI-84 calculator, you can see the symbol for natural log is LN, and it is right below the log button on your calculator. If you're in Desmos, you can just type LN, and we'll get into this more later. But a natural log is not a log of base 10 or base 5 or base 2. It's a log of natural base E. And you can see on my screen here that E is a number that is 2.718281, and it's a non-repeating decimal. It is a special number that was discovered by a mathematician named Euler, so it's called Euler's number, and it's used in calculations in finance with compound interest. If you're compounding continuously, you would use base E. Okay, so instead of writing a log base E of some number, we just shorten it to natural log, which is just ln of x. Okay, the way we say that is natural log of x. Okay, but that natural log is base E. It's the same thing as writing log base E. Okay, so that is a brief overview of Euler's number. If you want to know more about the number and where it comes from, we will get a little more into that in future lessons, but also you can watch the YouTube video that I'm attaching in Schoology if you would like to know a little bit more about it. Okay, so all of our log properties are still going to apply, and the inverse of log base E, or natural log, is base E. So all of our log rules that we know are still going to apply. So I think the best way to show you how to deal with natural logs is just to work some examples with you. So let's go ahead and do that. So we are going to have example 1. And part of this is going to be practicing calculator skills as well. So I have ln, didn't write that very well, ln, which is natural log of 72 equals x. So this is just practicing on your calculator or on Desmos. So in Desmos, you can just type ln 72 and it will give you a number. On your calculator, you can hit the ln button that's right below the log button and put in 72, and that will give you a number. So if you do either one of those things, you will get that natural log of 72 is 4.28. So make sure you're getting that. If you're not getting that, you're doing something wrong. Okay, so again, either in the calculator or Desmos. So let's try another one. If I say E squared is equal to x, okay? This is new, but you have to get in your mind that E is not a variable. E is natural log base E, and it stands for that certain number. But that number is so important that if you look on your calculator, you will see that if you hit second and natural log, it will give you an E to the x power, okay? So you can do that on your calculator. In Desmos, you can simply type E squared, and it will do this for you. So if you do E squared, you should get 7.37 equals x. So try out your calculator skills. Make sure you're getting those numbers. Okay, so let's look at solving some of these problems for x using our log properties that we know. All right, I'm going to say natural log of x is equal to 4. Now, if I wanted to solve this, and if it was a regular log, I would take the exponential base of both sides. Well, we're going to do the same thing. The exponential base, or the inverse of natural log, which is the same as base E, is taking exponential base E of both sides. Okay, so this is the same things we've been doing. You've just got to, it's a mind shift that you've got to get in your head that the base of a natural log is E. So, just like always, our base E and our natural log, which is base E, cancel out, and I get x is equal to E to the 4th power. And if I put that into my calculator or Desmos, I should get 54.60 if I'm rounding. Okay, so let's try another one. e to the x is equal to 7, and we're wanting to solve for x. So the inverse of exponential base e is log base e, which is natural log. So instead of writing it all again, I'm just going to squeeze my little natural log in right there, and I'm going to squeeze my little natural log in right there. And my natural log, which is log base e, and base e cancel out. And you're going to get better at this with practice. So x is equal to the natural log of 7. And if you put that into your calculator or Desmos, you will get 1.95. Okay? So let's try a couple more of these, and then I'll show you how to do it with the log properties. Okay, we're going to do e to the x minus 1 equals 9. So let's try this again. The inverse of base e is log base e, which is natural log. So I'm going to put natural log in front of each of my sides. Then natural log and base e cancel out, and I'm going to have x minus 1 on the left and natural log of 9 on the right. If you put natural log of 9 in the calculator, you get 2.20 is equal to x minus 1, and then we just add 1 to both sides. So I have x equals 3.2 or 3.20. Okay, so we're using our same log rules, and let's look at 2 more examples. Just showing you different types of problems that you could have. So we'll do natural log of x plus 2 equals 7. So remember, the inverse of natural log is exponential base e. So again, I'm going to take exponential base e on both sides. Base e and natural log cancels, and I'll have x plus 2 equals e to the 7th. And remember, you can pause this video as many times as you need to do your calculations. E to the 7th is equal to 1096.63. And now I just have to subtract 2. And I get x equals 1094.63. So you can see we're just using our same inverse operations that we have been using to solve these problems. Okay, let me do a couple more examples with you that, well, I'm just going to do 2 more using the log properties so that you can know how to solve a little bit more complex problems. So the log properties work exactly the same way as they did in regular logarithms. So let's look at the log properties again, this time with a natural log, okay? So with a natural log, if I have natural log of something plus natural log of something else, that's going to be the same thing as natural log of the product of those 2 things. In the same way, if I have natural log of x minus natural log of y, that's going to be condensed together as natural log of x over y. So you see it's the same properties that we had before, we're just doing natural log instead of log. And then the last one is if I have a number like, let's say 2 out in front of the natural log, that 2 can be brought, or whatever number is out there, can be brought up as an exponent inside of the natural log. So that would be natural log of x squared. So these are our log properties. They were valid for regular logs. They're valid for natural logs. They're valid for all logs. So let's look at 2 examples before we stop, and we'll use some of these properties. So I have natural log of x plus natural log of 4 is equal to 6. Okay, so as you can see, you've got 2 natural logs being added, And if I'm adding, I can use this first property and combine it into a single natural log of the product. So this is going to turn into the natural log of x times 4, which is 4x, equals 6. Now, I'm trying to solve for x and get the x out of the logarithm. So I've got to take it to the exponential base, and the exponential base of a natural log is e. So I'm going to do the exponential base on both sides. And remember that natural log and base e cancel, and I'm left with 4x equals e to the 6th. Now we can use our calculator to plug in e to the 6th, and we will get 403.43 is equal to 4x. And then finally, I will divide by 4, and I get x equals 100.86. Now, don't forget, when we're solving log problems, we have to check for extraneous solutions. And the way that we do that is we have to plug in our answer into our original problem. When we find out what x equals, we plug it back into x, and we make sure that my argument stays positive. So in this case, that would give me natural log of 100.86 plus natural log of 4 equals 6. My argument here is positive, so this solution is valid. Always check for extraneous solutions. Okay, one more example. So in this last one, we're going to use the other two log properties. So I'm going to say 2 natural log of x minus natural log of 9 is equal to 1. Okay, so let's look at how to combine things with our log properties. Let me shrink this down a little bit. We're going to use our second and third properties up here. But I have to use my third property, the power property, first, because I want to pull any coefficients into the natural log before I combine with the quotient property. So I'm going to take this 2 out front, and I'm going to pull it into the natural log as an exponent. So now I have natural log of x squared minus natural log of 9 equals 1. And now that I have natural log minus natural log, I can use the quotient property to pull those into 1 natural log as x squared over 9 equals 1. Now that I have a single natural log, I'm going to take the inverse of natural log, which is base e, to both sides. And we know that base e and natural log, which is base e, cancel out. And I'm left with x squared over 9 equals 1. Now, don't freak out about the fraction. I'm just dividing by 9, and the opposite of dividing by 9 is multiplying by 9. So I'm going to multiply both sides by 9, cancel that right out, and I have x squared equals 9. Finally, I'm going to take the square root of both sides. And remember, when you take the square root of 9, you get 2 answers. You have plus or minus 3. So that gives me 2 solutions. X is equal to 3 or x is equal to negative 3. And the very last thing we have to do is check to see if I have any extraneous solution. So if I look back at my original problem here, I have natural log of x. So if I take this first number and I plug my 3 in for x right here, I'm taking the natural log of a positive number, which is fine. So that one is valid. If I take my negative and I plop it in here, I'm taking the natural log of a negative number, and you cannot have a negative argument with a log. So I'm going to scratch that out and say that one is extraneous. So that is not a valid solution. It's extraneous. So I hope you found this helpful, and good luck on your assignment. It's very brief, and email me if you have questions, and I will see you guys soon. Take care.